All right, guys. Sorry to miss class today, but I figured we could do a quick review of exponents and polynomials real quick, kind of like what we did yesterday. And that way you can kind of get the general sense of things. Again, we're not going to be able to go into all the super details, but let's cover kind of the big stuff, important things you need to know, things you should go back and look at, etc. So we started with exponents. And if you go back and look at worksheet 1, which I highlighted here, okay, during that unit, it'll go over 6 important exponent rules to live by. I'm not going to run through all of them, but maybe some examples. Anything to the 0 power always equals 1, right? Anytime we have negative exponents, like x to the negative 2, we want to rewrite that as 1 over x squared. We had things like if you have x squared to the third, we multiply, we distribute, you get x to the sixth. If you're multiplying terms with the same base, x squared times x cubed, you get x to the fifth. Maybe I will run through all of them real quickly. If you're doing division, like 3 to the eighth over 3 to the fifth, you subtract the exponents and you get 3 to the third. Right, we use these enough, you probably know them by now. So it shouldn't be too big of a problem. If you have a fraction like 3 over 2 to the fourth, that's the same thing as 3 to the fourth over 2 to the fourth, right? So you can distribute them that way. So make sure you know those 6 rules. There's no if you don't know them, we use them enough in all sorts of other problems that you're going to be in trouble. Okay. We then started talking about adding and subtracting polynomials. So that was adding things like, 2xy to the fifth minus 5xy to the fifth. And as long as they had common terms, right, or what we call like terms, which they do here, we can subtract them just like kind of any other variable. So in this case, 2xy to the fifth minus 5xy to the fifth would be negative 3xy to the fifth. So we spent time looking at those types of problems. Okay, you can only combine like terms. And then we also spent time, I know I said adding and subtracting, we did multiplying. And if you remember, multiplying x plus 6 squared, for example, you cannot distribute the exponent. That was probably the number one dumb mistake I saw. Do not distribute the exponents, i.e., it's not x squared plus 6 squared, right? If you remember, we have to use a process that we call foiling, and we have to FOIL. Okay, so we saw a lot of that. Okay, we looked at special foiling patterns, perfect square foiling, and difference of squares. Okay, so that was things like, x plus b, a minus b. What does that FOIL to? We know the middle terms cancel out. I think we see it enough nowadays. We had a squared minus b squared. That's an important one because that's going to, if we remember, that pattern is going to help us when we factor. Okay, so we spent a lot of time just working on the the foiling, making sure if we're adding and subtracting, they have like terms, they have the same terms. Okay, so go back and look at those. Those were worksheets 2 and 3. Okay, we then spent a whole bunch of time factoring, and that's where we had special patterns like dots, right? Like we just saw above. That's when you have a squared minus b squared, and we recognize, oh, that factors to a plus b, a minus b. Okay, and it can get a little tricky if you have something like 4x squared y squared minus 9. That would factor to 2xy minus 3 and 2xy plus 3. So what you're really looking for in dots, if you remember, right, is that each term in the front is squared and each term on the back is squared. Okay, you need to watch out for those. So we saw a lot of dot stuff. If we remember when we factor regular trinomials, okay, things like 3x squared plus 6x plus 9, we always want to factor out a GCF first. Okay, always factoring out that GCF. Anytime we factor, if you can factor out a GCF, that's what we're going to do. Okay, and then we also looked at special patterns with cubes. So things like a cubed plus b cubed and a cubed minus b cubed. And those are patterns you just have to have memorized, okay? It's one of those things, we don't do a ton of memorization, but this is what we want to do. In this case, do some memorization. So a cubed plus b cubed, we called that SOTC, S-O-T-C, sum of two cubes. And that had a factoring pattern of a plus b times a squared minus ab plus b squared. And the difference of cubes, or what we called DOTC, right, was a minus b times a squared plus ab plus b squared. Okay, and we had a little acronym to help us remember it. Okay, it was SOAP, if you remember SOAP. Okay, let me actually undo the underlining. So the SOAP was same sign. So if we notice, if we look at SOTC, it's a cubed plus b cubed. So in the first parentheses we have, it was a plus b. Notice for DOTC, we had the minus, it was a cubed minus b cubed. So the first sign we had in the first parentheses was minus. Okay. Then we had OA, O, which was opposite. So it's going to be the opposite of the sign. So if we notice in SOTC, it's minus AB. It's the opposite of what we had originally, which was a cubed plus b cubed. And same thing for DOTC, we have a cubed minus b cubed. So this term in the middle, plus, will be plus AB. And then the last term is AP. That's always positive. That means your last term, when we do the plus b squared for either one, it's going to be always positive. Okay. There's a lot of different problems you can see. They can definitely get complicated. So my advice is just do a lot of practicing. Go back and look at worksheet 4 here. Has a lot of good practice problems. Okay. All right, take it back. We also had one more type of problem. That was where we had a regular trinomial. Okay, we had a regular trinomial, but we had, sorry, I'm thinking and talking at the same time. We had a coefficient other than 1, okay, leading up to it. So, for example, let's take negative 5x squared plus x plus 6. Okay, we use the AC method to factor it, right? And that involved just taking, right, the first term and the last term, which in this case would be 6 and minus 5. Okay. Oh, sorry, I take it back. We look at the product of 6 and 5. My fault. Product of 6 and 5. Product of 6 and negative 5 is negative 30. Right? And then we're looking for terms that multiply to negative 30 and add to positive 1 because I'm looking at this plus x term. It's positive 1x. So in this case, it would be plus 6 and minus 5. So I rewrote this as minus 5x squared plus 6x minus 5x plus 6. I'm just going to move this over here. And then I factored by grouping, right? I factored out an x out of the first two terms. So that gave me x times negative 5 plus 5x plus 6. And then I can factor a 1 out of the other two terms. So you have plus 1, and you're left with minus 5x plus 6. I'm running out of room here. And then I use factoring by grouping to do x plus 1, negative 5x plus 6. Okay, and now I factored it. That was a super short review of it. Go back and look at it. AC method. Okay, again, that was worksheet number 5. That'll help you factor trinomials. And after some factoring practice, we really ended with polynomial equations and polynomial inequalities. Okay, I don't know what happened there. But for equations, okay, we dealt with polynomial equations. We're just going to move all terms to one side. Move all terms to one side and factor. Okay, I'm going to put in a little do not divide by x. That is a major sin. It's on the 10 commandments of do not do's here in Algebra 2. So do not divide by x. If you do that, you lose the zero terms sometimes, okay? So do not divide by x when you're doing equations. Just move all the terms to one side and factor, and then solve for x. And then for inequalities, something like x squared minus 4 is greater than or equal to 0. If you remember, we factored these. So x plus 2, x minus 2. Okay, we temporarily set it equal to 0. If you want to leave it as greater than or equal to 0, that's fine. Why don't we do that here? And then we took the zeros of that function, negative 2 and positive 2, and we put it on a number line. If you remember, we put it on a number line, negative 2 and positive 2. Since it's greater than 0, greater than or equal to 0, we have closed circles, and then I tested those intervals. For example, I plugged in a value like 3 and saw if I plugged in 3, did it make this inequality true? And it does. If I plug in 3, I get 3 squared minus 4 is 5. That's greater than or equal to 0. So that means this inequality works. You can put a check. You can put a plus, whatever makes it easier for you. And when you plug in values in between negative 2 and 2, you'll find that you get the negative values. Oops. So we know it doesn't work there. If I plug in values less than negative 2, like negative 3, we find it does work. So we have to do, again, what we call an interval test. Okay. And we have to do that anytime we have something other than linear. Okay. We'll say other than linear. So those are things like x squareds, x cubes, x to the fourth, anything other than just, 2x plus 7 is greater than 0, we have to do interval tests. Okay, and that's what we focused on here. And then we write, if we go back to this problem, our answer in interval notation, we would go from negative infinity, where does it work, to negative 2, union 2 to infinity, and we're going to be inclusive of negative 2 and 2. Okay, so that was a really quick review that covers most of it at a high level. Certainly go back and look at all the details here because there's a lot to cover. But if you have questions, ask me tomorrow in class. Otherwise, good luck.